Okay, so we're gonna solve one more problem and I'm gonna call it a day. So this problem is taken from the textbook 6.51, available in the solution manual from the Fundamentals of Fluid Mechanics, edition 4, by Munson, Young, Okishi, and Abish. Now, the problem states we have a potential flow against a flat plate is given by the stream function AXY, where A is a constant. At the stagnation point O, add a source. That's the second picture of strength M, and a bump is obtained. Determine the ratio between the height h, the constant A, and the source M. Okay, so I just want you to not be intimidated with the question. Basically what this question is saying, okay, I have a stream function given in this form here. I want you to add the source on it, and I want you to find the new stagnation point. Originally it was at O. Now because I put a source, it's going to go up. So I'm going to want you to find the new stagnation point relationship. Again, I would follow the steps, and as I follow the steps, things will be clearer. Don't get intimidated with the question, just try to follow the steps. Now, the first step, number 1, is to construct my flow by using the superposition of the given function and my source. Again, why did I use the stream function xi? That's because I want to work with theta and I don't want to work with lnr. It's your preference, whichever way you feel more comfortable, you can do that. So let's solve this problem here. So I have identified my two flows and I'm going to add them up here. So I'm going to end up having a xy plus the source is m over 2 pi theta. That's my side. Now again, I have the same problem. I cannot be working in two different coordinate systems. I cannot work in x, y, r, and theta. I cannot work in Cartesian and cylindrical. I have to choose one. So for convenience, I'm going to convert my x and y to r and theta and end up having r cos theta times r sine theta plus m over 2 pi theta. Now if I multiply these two guys together, I'm going to get a r squared cosine theta times sine theta. I'm going to get sine 2 theta plus m over 2 pi theta. This one is over 2. Now, this is my first milestone. Step number 2, according to our sequence, is to find u and v for vr and v theta. Because we're working r and theta, we're going to go find vr and v theta. Vr is given by 1 over r, d psi by d theta. So that would give me 1 over r. So I'm going to be left up with an r. My a is a constant. Sine, I have sine 2 theta over 2. I differentiate, I'm going to get 2 cos 2 theta. So 2 cancels 2. I'm going to be left up with this plus my 1 over r. I'm going to have m over 2 pi r. Next I have v theta. It's minus d psi by dr. I'm going to differentiate my function. I will get here, I'm differentiating with respect to r. I'm going to have 2. 2 is going to cancel the 2. I'm going to end up getting a r sine 2 theta. Okay, so I have my next milestone. When I get to this part, means I'm 70% done with my problem, and I assured I'm going to get a lot of partial marks. Okay. Now I have to find the new stagnation point on my graph. So if I'm working if you picked your Cartesian coordinates and you have x and you have y, in this form your point is going to be located at x equals 0 here, and your height, your y, is going to be h. If you're working in cylindrical, this is Cartesian. Looking in cylindrical, your stagnation point is going to be equal, again, your r, your radius is h, and your angle theta is pi over 2. So let's do green. Okay, so imagine this, and this is theta, and this is r, so it's equal to h. So we're going to use these 2 points. Okay, now I'm going to replace my stagnation point coordinates, which is, let's call it point P, h, and pi over 2. Okay, so let's replace h and pi over 2 in VR. What will I get? If I replace it in VR, I'm going to get here VR equals h cos pi plus m over 2 pi h. Now because it's a stagnation point, my VR is equal to 0, so I'm going to get this relation. Or AH minus cosine pi is minus 1 equals m over 2 pi h. AH is m over 2 pi h plus h squared equals m over 2 pi a. And that's a relation between the height h, m, and the constant a. So here's the problem solved.